Hey there, future robot wranglers. Ready to dive into the world of programming? You ever wonder how robots do those amazing things? How they seem almost magical in their abilities? Like, how does a self-driving car know where to go and avoid obstacles on the road? Or how does a robot arm in a factory know how to put together a smartphone with such precision? The answer is simple: programming. It's the magic behind the scenes. Think of it like this. Robots are like really cool bodies, but without a brain, they're just lumps of metal and plastic, unable to do anything on their own. That's where programming comes in. It breathes life into these machines. Programming is like giving a robot a brain, a set of instructions that tell it what to do and how to do it, step by step. Just like you need instructions to bake a cake, robots need detailed instructions to perform any task. These instructions are written in languages they understand, like Python and C++. Each line of code is a command. We'll dive into those soon. Get ready to learn the languages of the future. Without programming, robots wouldn't know how to move, sense their surroundings, or do any of the cool things they do. They'd be lost. So, if you want to be a robot master, learning to program is the first step. Let's embark on this exciting journey together. Now, robots don't all speak the same language, just like people. Two of the most popular robot languages are Python and C++. They're like the English and Spanish of the robot world. Python is like a friendly chat with your robot buddy. It's easy to learn and great for beginners. Python is super versatile and can handle tasks like controlling sensors, processing images, and even making decisions based on data. Think of it as the Swiss Army knife of robot programming. C++ is more like giving your robot super detailed instructions. It's a bit tougher to learn, but it gives you a lot more control over the robot's hardware. C++ is perfect for robots that need to move fast and do complex things, like self-driving cars or robots working in dangerous environments. Which language should you learn? Well, it depends on what you want your robot to do. But don't worry, you can always learn both and become a true robot polyglot. Okay, so you've got your robot brain, programming, and you know how to talk to it. Python or C++. Now, you need to give your robot some instructions, right? That's where algorithms come in. Algorithms are like recipes for robots. They're step-by-step instructions that tell the robot how to do something specific. Let's say you want your robot to find the shortest path through a maze. You'd need to program an algorithm, like the breadth-first search algorithm, to help it find its way. Algorithms are all about problem solving. By breaking down a big problem into smaller, manageable steps, you can teach your robot how to tackle all sorts of challenges. The more algorithms you learn, the smarter your robot becomes. Think of it like this. If programming is giving your robot a brain, then algorithms are the thoughts and strategies that brain uses to solve problems and achieve its goals. Pretty cool, right? Robots are great at collecting information from the world around them using sensors. They're like robot senses. But all that information needs to be stored and organized somewhere, right? That's where data structures come in. Think of data structures like different containers for storing different types of information. Arrays are like neat rows of boxes, perfect for storing lists of things, like the coordinates of obstacles your robot needs to avoid. Lists are more flexible, like bags that can hold a mix of different data types, handy for storing sensor readings over time. Then we have trees. Imagine a family tree, but for data. Trees are great for organizing information hierarchically, like mapping out all the possible moves in a game of chess. Data structures help your robot make sense of the world by providing organized ways to store and access information. It's like giving your robot a well-organized memory bank. Section 5. Robot Autopilot. Control systems and feedback loops. Imagine you're building a robot arm to pick up objects. This robot arm needs to be precise and reliable in its movements. You tell it to move to a certain position, but how does it know how much to move its motors and when to stop? This is a crucial question in robotics. That's where control systems come in. They are the backbone of any automated system, ensuring everything works as intended. They're like the autopilot for your robot, making sure it moves smoothly and accurately. Without them, the robot would be erratic and unreliable. One common control system is called PID control. PID stands for proportional, integral, and derivative. It's like a robot chef constantly adjusting the temperature of an oven to bake the perfect cake. The robot chef ensures the cake is neither undercooked nor burnt. PID uses feedback from sensors to adjust the robot's movements in real time. This feedback is crucial for maintaining accuracy. It measures the error, or how far off it is from the desired state, and adjusts its output to minimize that error. This continuous adjustment is what makes the system effective. For example, if the robot arm is moving too fast towards an object, the PID controller will detect this and reduce the motor speed, ensuring a gentle grasp. This prevents damage to both the object and the robot. Control systems are essential for giving robots the ability to interact with the world in a precise and controlled manner. They are the unsung heroes behind the scenes, making sure everything operates smoothly. Section 6. Robots with a Sixth Sense. AI and Machine Learning in Robotics. Ready for some next-level robot stuff? Artificial intelligence, or AI, and machine learning are like giving robots a sixth sense. They allow robots to learn from data, adapt to new situations, and even make decisions on their own. Imagine training a robot to recognize different objects, like a dog versus a cat. Instead of programming in every single feature, you can use machine learning algorithms to train the robot on a dataset of images. The robot learns to identify patterns and distinguish between objects, just like our brains do. AI and machine learning are revolutionizing robotics, enabling robots to perform complex tasks that were once thought impossible. Libraries like TensorFlow and PyTorch provide powerful tools for building and deploying machine learning models in your robot projects. It's a whole new world of possibilities. Section 7. Robot Symphony Conductor. ROS for Orchestrating Components. Building a complex robot is like putting together a giant puzzle. You have different parts, like sensors, motors, and software, that all need to work together seamlessly. That's where the Robot Operating System, or ROS, comes in. Think of ROS as the conductor of a robot symphony orchestra. It provides a framework for connecting all the different parts of your robot and allows them to communicate with each other. ROS makes it easy to share data between different components, coordinate complex movements, and even control your robot remotely. With ROS, you can focus on building individual robot capabilities, like navigation or object recognition, without worrying about how to connect everything together. It's a powerful tool for building sophisticated robots and collaborating with other robot enthusiasts. Section 8. Your First Robot Steps. Resources and Projects for Beginners. Feeling excited about robotics? Awesome! You're about to embark on an incredible journey. The best way to learn is by doing. Hands-on experience is invaluable. Here are a few practical starting points for budding robot builders. Start small. Don't rush into complex projects. Begin with a simple robot kit, like an Arduino-based robot car. These kits are user-friendly and perfect for beginners. These kits provide a great introduction to basic electronics and programming concepts. Explore online resources to deepen your knowledge. Websites like Khan Academy, Coursera, and edX offer free or affordable courses on programming, robotics, and AI. These platforms are excellent for structured learning. YouTube channels like Boston Dynamics and Make are great for inspiration and tutorials. They provide visual and practical insights. Join the community. Connect with other robot enthusiasts online or at local robotics clubs. Networking can open up new opportunities and ideas. Sharing ideas and collaborating on projects is a fun and rewarding way to learn. Project ideas. Here are some to get you started. Build a robot that follows a line, avoids obstacles, or solves a maze. These projects are challenging yet achievable. Experiment with different sensors and actuators to create unique robot behaviors. This will enhance your understanding of robotics. Remember, the only limit is your imagination. Think outside the box and innovate. So, what are you waiting for? The world of robotics is at your fingertips. Dive into the world of robotics and start building the future, one line of code at a time. Your journey begins now.